Welcome to Dreamtime Science, where curiosity meets tranquility and knowledge flows like a gentle stream. Here we explore the wonders of our universe at a pace that soothes the mind. You know what's fascinating? I've been thinking about how something as powerful and fiery as a volcano starts quietly deep beneath the earth, almost like a slow-building story that finally bursts into a dazzling show. There's something remarkable about the journey magma takes before it becomes that glowing river of lava we see, and I can't wait to share the surprising ways this hidden process unfolds beneath our feet. Should these dreamy explorations accompany your journey to sleep, a gentle like or subscription would be deeply appreciated. What questions about our universe keep you wonderfully curious? Now, take a moment, adjust your blanket, find the perfect hollow in your pillow, let your shoulders melt, breathe in and out. Beneath the hush of evening, as shadows lengthen and the world settles into softness, let us turn our thoughts to the most ancient and dramatic of Earth's storytellers, the volcano. There is something almost primordial in their presence, a force both terrifying and alluring, a paradox at the heart of our planet's restless soul. Volcanoes are the wounds and forges of continents, the breath of the earth itself, rising in towers of fire and ash that touch the sky and shape the land below. Long before science would find the words for magma and tectonics, people watched these mountains wake and slumber, their summits wreathed in smoke, their flanks trembling with fire. To live near a volcano was to dwell on the edge of mystery and danger, to see the world as alive with powers beyond the ordinary. Myths grew up like forests around these fiery peaks, and the stories they inspired still flicker at the edges of our imagination. Consider the name itself, Volcano, drawn from the Roman god Vulcan, master of fire and forge, whose hammer rang beneath the mountains, shaping weapons for gods and mortals alike. The ancients believed that somewhere deep beneath the crust, divine smiths toiled in infernal workshops, their anvils the cores of the world's most fearsome mountains. From these subterranean realms came not only destruction, but also creation, new land, fertile soil, and the metals upon which civilizations would be built. In every eruption, people sensed the hand of the divine, a message, a warning, a promise. But let us step further back into the tapestry of imagination that predates even Rome. Across the Mediterranean, the Greeks saw the fires of Mount Etna as the breath of Typhon, a monstrous serpent buried by Zeus beneath Sicily, his rage venting through the earth. Far to the east, the Japanese revered Mount Fuji as a sacred presence, a threshold between worlds. In Hawaii, Pele, the goddess of fire, danced through the lava flows, her footsteps shaping the islands themselves. In every culture that lived within sight of a smoking summit, volcanoes became portals to the underworld, places where the skin of the world was thinnest and the hidden heart of things might break through. In Iceland, where the land itself is a patchwork of old and new lava, the sagas tell of giants and trolls shaped from stone, their struggles petrified in basalt. The Norse called the world's first fire Muspelheim, a realm of flame and chaos out of which the cosmos was born. Even in the coldest reaches, the memory of fire lay coiled at the roots of myth. To speak of volcanoes, then, is to speak of both fear and fascination. They are destroyers, yes, but also creators. Their eruptions can bury cities, but also give birth to new land. Even after devastation, life returns, lush, unexpected, profuse. Volcanic ash settles into the richest soils, nurturing vineyards and forests. The black rock cools, splits, and is colonized by moss and fern, then by tree and animal. The violence of the volcano is the violence of renewal, the world remaking itself before our eyes. We see this duality reflected too in our stories. Nowhere does this dance of fire and shadow come alive more vividly than in the pages of J.R.R. Tolkien's Legendarium. Tolkien, a writer whose imagination was shaped by the landscapes of his youth and the ruins of ancient myth, gave us perhaps the most iconic volcano in all of fantasy, Mount Doom, or Orodruin, the beating heart of Mordor. In the world of Middle-earth, Mount Doom is no mere backdrop. It is a character, a presence, a force. Its red eye glows in the perpetual twilight of Sauron's domain, watching, waiting. Its eruptions are the pulse of evil, echoing the dark will of the ring's master. The mountain is both a prison and a crucible, the place where the One Ring was forged, and the only place where it can be unmade. Around it lies a blasted land of ash and slag, a landscape scarred by fire and shadow. Tolkien's vision of Mordor, that bleak and haunted land, draws on the imagery of real volcanoes, their power and desolation, but it is also a place steeped in the memory of myth. The very name Orodruin, Mountain of Fire, speaks to ancient languages and older fears. The journey to its summit is a descent into the underworld, a trial by fire that echoes the oldest stories of gods and heroes. It is tempting to see Mordor as pure invention, a landscape born only in the mind of its maker. Yet Tolkien was, above all, a lover of the real world, a scholar whose imagination was nourished by the landscapes of England, by tales of Iceland, by the echoes of Roman and Norse myth. He walked among the ruins of ancient volcanoes on the British Isles, visited the blackened craters of old eruptions, and read the accounts of travellers who had seen Vesuvius or Stromboli in full fury. There is a moment, early in the tale of The Lord of the Rings, when Frodo and Sam first glimpse the far-off glow of Mount Doom, a red wound on the horizon. The air is thick with ash, the sky veiled by a perpetual twilight. It is not only the land that suffers, the very air is poisoned, the water fouled. This is not invention alone, but a reflection of what real volcanoes can do. When Vesuvius erupted in 79 AD, the sky was darkened midday. The sun turned to a wan disk behind curtains of ash. In the aftermath, the city of Pompeii was entombed, its people caught in a moment of terror and wonder. And yet, even in the shadow of such destruction, life returned. In the centuries that followed, the slopes of Vesuvius became some of the richest farmland in Italy. Grapes and olives thrived in the volcanic soil, their roots digging through layers of ash and pumice. The old Roman name for the region, Campania Felix, the fortunate countryside, speaks to this paradox. The mountain that destroyed could also bless. Tolkien understood this cycle of destruction and renewal. His Mordor is not simply a place of evil, but a landscape shaped by ancient fire. The land is wounded, yes, but also restless, alive. The volcano at its heart is both threat and promise, the end of things and their beginning. Where, then, did Tolkien find his inspiration? Some have guessed that the dark wastes of Mordor echo the blasted fields of France and Belgium, where Tolkien fought in the First World War. The blackened earth, the poisoned air, the endless mud. These are the scars of war, writ large upon the imagination. And yet, the vision of Mount Doom is older still, rooted in the deep time of geology. There are places on earth where the land is marked by a similar hand. In the highlands of Iceland, one finds fields of jagged lava, twisted and black, stretching to a horizon of steam and snow. Here, volcanoes rise from the plain like the bones of giants, their summits lost in cloud. The ground itself is hot, cracked, alive with the scent of sulphur. To walk here is to feel the world unfinished, the crust thin and uncertain. The great Icelandic volcano Hekla, once feared as the gateway to hell, erupts with a violence that echoes the tales of Muspelheim. Its flows of lava consume all in their path, yet in time the land is reborn, green and fertile. The sagas tell of men who ventured into these wastes and returned changed, touched by the fire at the heart of the world. Further south, in Italy, the volcanoes of Etna and Vesuvius have shaped not only the land, but the stories people tell. Etna, in particular, was seen as the forge of Hephaestus, the Greek god of fire and craft. The mountain's eruptions were the sparks from his anvil, the smoke, the breath of his bellows. In the shadow of Etna, the ancient city of Catania thrives, its streets paved with black basalt, its gardens lush and green. It is no wonder, then, that Tolkien, a scholar of myth and language, would draw upon these real-world wonders in crafting his own. The landscapes of Middle-earth are not merely fantastical. They are rooted in the deep memory of the earth, in the way that fire and stone shape both land and story. But to truly understand the power of volcanoes, we must look beneath the surface to the forces that drive them. Deep within the planet, far below the crust, lies a realm of heat and pressure. Here, rock is not solid, but molten, a churning sea of magma. The crust above is cracked and restless, broken into vast plates that slide and collide. Where these plates meet, the pressure builds, and the molten rock finds its path upward, seeking release. When the pressure becomes too great, the earth yields. Magma bursts forth, carrying with it the gases and minerals of the underworld. The eruption is both sudden and ancient, a reminder of the planet's restless youth. Ash and lava spill across the land, reshaping mountains, filling valleys, forging new ground. For those who watch from afar, an eruption is a spectacle, a fountain of fire against the night sky, a river of molten rock glowing red and gold. But for those who live in the shadow of the volcano, it is a presence both intimate and unpredictable. The ground trembles, the air thickens, the sky darkens. In that moment, the boundary between the world above and the world below seems to thin, and the old stories come alive. It is this sense of awe and uncertainty that has kept volcanoes at the heart of human imagination. They are, in a sense, the Earth's own storytellers, speaking in tongues of fire and stone. Their eruptions are both a warning and an invitation to remember that we live upon a living planet, one whose heart is not cold, but burning. Tolkien's Mount Doom is the ultimate expression of this idea, a mountain whose fires are the key to both power and destruction, whose slopes are the stage for the final act of an epic struggle. To climb its heights is to confront not only danger, but destiny. The path is hard, the air thin and acrid. Each step is a trial, each breath a victory over fear, and yet, even here, there is beauty. The light of the volcano paints the clouds in colours unseen elsewhere, a palette of red and gold and black. The heat that scorches also illuminates, revealing the bones of the world. The mountain stands as both threat and guide, a beacon in the darkness. So, as we let our minds drift over the landscapes of myth and memory, let us remember the volcano, not only as a force of destruction, but as a forge of worlds. In its fires we see both the end and the beginning, the possibility of ruin and the promise of renewal. The dance of dragons and gods, of heroes and monsters, is also the dance of the planet itself, ever turning, ever changing. The journey into the heart of fire has only just begun. Somewhere ahead, the secrets of the forge await, hidden in the shadows and the glow, calling us onward into the depths of Vulcan's domain. Beneath your feet, beneath the tapestry of green forests and the languid drift of rivers, a different world stirs, a world where stone is soft and time flows in currents of heat. If you could slip through the crust of the earth, past the roots of mountains and the whispering aquifers, you would find yourself in a realm of perpetual twilight. Here the air would shimmer with the ghostly breath of minerals, and the very walls would pulse with an ancient, slow heartbeat. This is the labyrinth of lava, deep within the living anatomy of a volcano. In the popular imagination, volcanoes are simple things, mountains that spew fire, churning cauldrons ready to burst. But the truth, as is often the case in nature, is more subtle and far stranger. Let us move, step by step, through this labyrinth and see how a volcano truly lives, how it gathers its strength, and how it finally releases its pent-up fury in a dazzling, destructive dance. The journey begins in darkness, far below the crust, what geologists call the lithosphere. Here, the temperature climbs inexorably, and the weight of the world above presses down with unimaginable force. The rocks are not truly liquid, nor are they quite solid. Rather, they exist in a twilight state, plastic and mutable, able to flow only over the slow course of centuries. This mantle is the birthplace of magma, but magma does not exist everywhere, nor does it form all at once. Its genesis is a delicate ballet of pressure, temperature, and chemistry. Magma is born when conditions conspire to melt the solid rock of the mantle. This can happen in several ways. Sometimes, as tectonic plates grind and dive beneath one another, water and other volatiles are forced down into the mantle. These substances act like salt on icy roads, lowering the melting point of the rock. In other places, the mantle itself rises, decompressing as it ascends, and the reduction in pressure allows it to melt. Occasionally, a mantle plume, a column of hot, buoyant rock, rises from deeper still, carrying heat from the planet's core like a torch. Each of these processes can give birth to the molten rock that will, in time, become magma. But magma, once formed, does not immediately rush toward the surface. Instead, it gathers in secret chambers deep beneath the Earth's skin. These magma chambers are not vast, empty caves filled with bubbling lava, as some legends might suggest. Rather, they are more like sponge-filled pockets within the rock, where molten stone infiltrates and saturates the surrounding minerals. The chamber swells, sometimes for centuries, as pulses of new magma arrive from below, each one subtly altering the chemistry and temperature of the growing reservoir. Within this chamber, a complex drama unfolds. Magma is not a homogeneous soup. It is a mixture, a suspension of melted silicates, dissolved gases, and crystals. As it sits in the chamber, it cools ever so slightly, and minerals begin to crystallize out of the melt. First olivine and pyroxene, then feldspars and quartz, each according to their solubility and the temperature of the chamber. These crystals sink or float, changing the composition of the remaining magma. The denser, heavier minerals settle, leaving behind a lighter, silica-rich melt that may be more prone to violence when it finally erupts. This process, called fractional crystallization, is one of the many ways a volcano evolves internally, shaping the nature of its eventual eruption. A magma rich in basalt, dark and fluid, will produce rivers of glowing lava that race down the mountain's flanks. A magma richer in silica, thick and sticky like honey, will trap gases and build pressure, setting the stage for a more explosive finale. Here too, in these secret chambers, lies one of the great myths of volcanology, the notion that volcanoes explode because the magma below is simply too hot, too restless to be contained. But heat alone is not the architect of eruption. The true driver is pressure, and the most important ingredient is not stone, but gas. Water vapor, carbon dioxide, sulfur dioxide, and a host of lesser volatiles are dissolved in the magma, trapped within it by the immense pressure of the overlying rock. As the magma rises, that pressure drops, and the gases begin to exsolve, coming out of solution like bubbles in a shaken bottle of soda. If the magma is runny, like basalt, these bubbles can escape easily, and the eruption tends to be gentle, producing fountains and flows. But if the magma is viscous, the bubbles cannot escape. They build up, straining against the confining rock, until finally, explosively, they burst free. This is the secret heart of volcanic fury, not the boiling heat, but the trapped breath of ancient oceans and primordial air seeking release. The journey of magma from chamber to surface is neither swift nor certain. The Earth's crust is a maze of fractures, faults, and weaknesses. Sometimes the pressure of gas-laden magma will exploit a fault, forcing its way upward in a thin, needle-like dike. Other times the magma will pool in sills or find itself trapped, cooling and crystallizing, never to see the light of day. Only rarely does the magma find a pathway all the way to the surface, and when it does, the stage is set for eruption. The moment of eruption is a study in contrasts, between violence and beauty, between destruction and creation. The first sign is often subtle, a trembling in the earth, the prelude of harmonic tremors as magma forces its way through rock. The ground may swell imperceptibly at first, then by centimeters or even meters in the final days. Fumaroles, vents of steam and gas, may appear on the flanks of the volcano, their plumes carrying the acrid scent of sulfur. Then, at last, the eruption begins. Popular images focus on catastrophic explosions, showers of ash and stone, rivers of fire. But eruptions are as varied as the volcanoes themselves. Some, like those in Hawaii, produce slow, mesmerizing flows of lava, glowing red against the night, advancing inexorably but with little violence. These are the effusive eruptions, the gentle outpourings of basaltic magma. Others, like the infamous Mount St. Helens or Krakatoa, erupt with terrible force. Here the magma is thick with silica, sticky and unwilling to let go of its gases. When the pressure becomes too great, the rock above shatters, and a column of ash, gas and stone is blasted skyward, sometimes reaching the stratosphere. Pyroclastic flows, clouds of incandescent ash and gas, race down the slopes at hurricane speeds, obliterating all in their path. These explosive eruptions can reshape landscapes, darken skies, and alter climates. And yet, even in these moments of fury, the volcano is not simply a destroyer. With each eruption, it builds as well as tears down. Layer upon layer of ash and lava accumulate, growing the mountain higher, giving birth to new land where once there was only sea. The soils left in the wake of eruptions are often among the most fertile on Earth, rich in minerals, ready to nurture new life. It is tempting to view volcanoes as unpredictable, as forces of chaos that erupt without warning. But this too is a myth. Volcanoes speak if one knows how to listen. Seismographs record the tremors of moving magma. Ground deformation reveals the inflation of swelling chambers. Gas sensors sniff out the changing breath of fumaroles. Modern volcanology is a science of subtle clues, of listening carefully to the murmurs beneath the earth. While prediction is never perfect, nature reserves her right to surprise. Many eruptions now come with warning, precious hours, or even days in which to prepare. The labyrinth we have traversed so far is shaped not only by the physical forces of rock and gas, but by the slow, patient work of time. Volcanoes are not monuments, but actors in an ongoing play, a cycle of birth, growth, collapse, and renewal. An eruption may empty the magma chamber, leaving a void that causes the summit to collapse inward, creating a caldera. Over millennia, the chamber may refill, and a new cone may rise from the ashes of the old. Some volcanoes are fleeting things, active for a few eruptions before falling silent. Others endure for millions of years, their histories written in layers of stone. Let us pause for a moment to walk within the cooled veins of an ancient volcano, a place where the molten labyrinth has frozen into stone. The walls here are streaked with bands of color, each representing a different pulse of magma, a different chapter in the history of eruption. Embedded within the rock are crystals, some large and well-formed, grown slowly in the warmth of the chamber, others tiny and chaotic, flash-frozen in the violence of eruption. There are pockets where gas bubbles once pressed against the confining rock, now preserved as hollow vesicles, tiny monuments to the volatile breath that powered the volcano's fury. Here and there the rock is riddled with fractures, the pathways through which magma once surged toward the surface. These dikes and sills are the petrified arteries of the volcano, a record of its restless searching for release. If you listen closely, you might imagine the echo of old tremors, the ghostly memory of pressure building and release. Among these cooled stones, one might also find evidence of the life that comes after fire. Lichens cling to the bare rock, their acid slowly etching new soil from the glassy surface. In cracks and hollows, the first seeds take root, nourished by the minerals left behind. Over decades, a barren lava flow becomes a forest, a testament to the creative destruction that is the volcano's true legacy. Still, myths linger. Ideas that volcanoes are always on the verge of eruption, or that every rumble portends disaster. In truth, most volcanoes spend the vast majority of their existence in silence, their chambers slowly filling and emptying, their slopes eroding under wind and rain. Some will never erupt again, their labyrinths frozen forever. Others bide their time, gathering strength, waiting for the next alignment of pressure and pathway. Perhaps the greatest myth of all is that volcanoes are merely destructive, that their role is only to threaten and terrify. Yet, without their ceaseless labor, the continents themselves would be worn away by rain and wind. The oceans would swallow the land, and the rich soils that feed our fields would be lost. The labyrinth of lava is not only a crucible of destruction, but a wellspring of renewal, shaping the face of the earth across the sweep of deep time. As we leave the heart of the volcano, trailing the path of magma from its secret chamber to the tumult of eruption, we carry with us a sense of awe, not only for the power unleashed, but for the patience and complexity with which it is prepared. The volcano is both artist and architect, destroyer and creator, its labyrinthine heart beating quietly beneath the surface, waiting for the next pulse of molten life. Above ground, the night sky glows faintly with the reflection of distant fires, and the ground beneath is warm with memory. The labyrinth is never truly still, never truly silent. Its slow, persistent rhythms echo through stone, through soil, through the roots of forests and the bones of mountains. And so the volcano waits. In its depths, the next journey of magma is already beginning, the next chapter of fire and renewal being written, line by molten line. What happens when the labyrinth's power meets the world above, how life and landscape are changed, remains to be explored as the story of the volcano continues to unfold, ever unfinished, ever mysterious. In the shadow of a restless volcano, where the ground trembles with ancient power and the air shimmers with heat, a new breed of explorer rises, a scientist as daring as any knight of old. Their armor is woven from flame-retardant fabric, their steeds are battered four-wheel drives, and their quests are written not in fairy tales, but in the annals of Earth's most volatile landscapes. They are volcanologists, guardians and chroniclers of the deep, those who court the fiery heart of our planet for knowledge rather than conquest. The tale of volcanology is not merely a catalogue of tools or a sterile inventory of data. It is a living epic written in sweat, courage, and the relentless curiosity that draws humans to the edge of the abyss. The story begins centuries ago, in an era when volcanoes were not yet understood as geological phenomena, but were instead seen as the wrathful mouths of gods or gateways to the underworld. The ground would shudder, fissures would tear open, and smoke would coil towards the heavens, omens of doom, portents of divine displeasure. Yet even then, there were those who peered closer, who sought meaning in the chaos. One of the earliest chroniclers was Pliny the Younger, who, in the year 79 AD, described the catastrophic eruption of Mount Vesuvius. His letters, vivid and detailed, mark the dawn of systematic volcanic observation. He wrote of the strange cloud, shaped like a pine tree, that rose above the mountain, of the darkness at noon, and the rain of ash that smothered Pompeii. His uncle, Pliny the Elder, perished in the Inferno, a victim of both curiosity and courage. In the centuries that followed, the Plinian eruption became a template for scientific inquiry, a reminder that to understand a volcano, one must sometimes get dangerously close. As centuries drifted by, natural philosophers mapped the world's volcanoes in ink and parchment, their notes interwoven with myth and hearsay. It was not until the Enlightenment that a more systematic approach began to take root. Scientists such as Sir William Hamilton, the British envoy to Naples in the 18th century, documented eruptions with painstaking detail and sketched the molten rivers that poured from Vesuvius. Hamilton's observations were both artistic and empirical, blending the romantic with the rational. He climbed the slopes himself, collecting rocks and gases, and sent his findings back to the Royal Society in London. His work laid the foundation for what would become the modern science of volcanoes. But the tools of Hamilton's day, quills, sketchbooks, and glass jars, were ill-matched to the violence of the volcanic world. The next leap came with the Industrial Age, when railroads and steamships shrank continents and made the world's volcanoes more accessible than ever before. Scientists could race to the scene of an eruption, bringing with them not just notebooks, but barometers, thermometers, and early seismographs. One of the most pivotal moments in volcanology's evolution arrived in 1883, when Krakatoa exploded in the Sunda Strait. The eruption was heard nearly 3,000 miles away and unleashed a tsunami that circled the world. In the aftermath, scientists measured the shock waves that rippled through the atmosphere, and for the first time, a global network of observation was born. Yet for all its scientific progress, volcanology has always demanded more than detached observation. It is a science of immersion, a willingness to get close to the furnace, to risk both body and instrument. In the early 20th century, this spirit was embodied by Thomas Jagger, an American geologist who founded the Hawaiian Volcano Observatory on the rim of Kilauea. Jagger's dream was to build a permanent outpost at the edge of the crater, a place where scientists could live and work in the presence of fire. He installed seismometers to record the tremors of the earth, tilt meters to measure the subtle swelling of the land before eruptions, and gas collectors to sample the breath of the volcano. The observatory became a beacon for volcanologists everywhere, a place where danger and discovery walked hand in hand. From these early beginnings, the tools of the volcanologist have both multiplied and refined. Modern researchers wield an arsenal of technology, each device designed to pierce the mysteries of the volcano without succumbing to its fury. There are thermal cameras that see through smoke and darkness, mapping the heat signature of lava flows in radiant color. There are drones, nimble, uncrewed scouts that can fly above the crater's maw, collecting gas samples and snapping high-resolution images where no human could safely go. There are spectrometers that sniff the air for sulfur dioxide and carbon dioxide, analyzing the chemical whispers that often precede eruptions. But for all the sophistication of their gadgets, volcanologists remain hands-on scientists, forever drawn back to the edge. They climb the unstable slopes to hammer loose a chunk of fresh lava, knowing that each rock records a unique moment in the volcano's history. They plunge probes into bubbling hot springs, their gloved hands steady despite the scalding spray. They hike across fields of ash, boots sinking into powder still warm from the last eruption, ears attuned to the rumble beneath their feet. Each expedition is a blend of calculation and improvisation, for no two volcanoes are exactly alike, and each demands its own strategy. The experiments devised in these crucibles of fire are as varied as the volcanoes themselves. In the high Andes, researchers have drilled into the ice-capped peaks to retrieve cores that contain layers of ash from eruptions centuries past, a frozen archive of the volcano's moods. In Iceland, a land where fire and ice entwine, they have mapped subterranean magma chambers using the echoes of man-made explosions, a kind of geological sonar that reveals the hidden plumbing of the Earth. In Japan, scientists have embedded networks of sensors around Mount Sakurajima, measuring the faintest tremors and gas emissions in real time. This web of data allows them to issue timely warnings, sometimes with only hours to spare, saving lives when the mountain awakens. Yet even the best instruments can only do so much. The unpredictable nature of volcanoes means that fieldwork is often a dance with danger, a test of both nerve and adaptability. The annals of volcanology are filled with tales of close calls and narrow escapes, of researchers trapped by sudden lava flows, of camps buried by ash, of helicopters buffeted by the hot, turbulent air above an erupting cone. Some of the most celebrated volcanologists have paid with their lives. Katia and Maurice Kraft, the intrepid French couple whose films and photographs brought the world face to face with volcanic fury, perished in 1991 on the slopes of Mount Unzen in Japan, caught in a pyroclastic surge they could not outrun. Their legacy endures in the images they left behind: rivers of molten rock, lightning-flecked ash clouds, the red glow of lava beneath a starless sky. Through their eyes, the public glimpsed both the beauty and the terror of these geological giants. For those who survive, the rewards are profound. Each successful expedition brings new insights into the workings of the planet. By studying the chemistry of volcanic gases, scientists can infer the depth and composition of the magma below, piecing together a picture of the volcano's inner life. By analyzing the shapes and sizes of volcanic crystals, they can reconstruct the temperature and pressure conditions within the Earth, like detectives sifting through the ashes of a crime scene. By mapping old lava flows and tephra layers, they can trace the history of past eruptions, identifying patterns that may hint at the timing of future ones. One of the most innovative techniques developed in recent decades is satellite remote sensing. From orbit, satellites equipped with radar and infrared sensors can monitor thousands of volcanoes simultaneously, detecting subtle bulges in the land or hotspots of rising heat. These eyes in the sky can spot the earliest stirrings of unrest, even in places too remote or dangerous for human observers. When Mount Pinatubo in the Philippines began to rumble in 1991, satellite data helped confirm that the volcano was swelling and that an eruption was imminent. The subsequent evacuation saved tens of thousands of lives. Yet for all their technological marvels, volcanologists remain, at heart, storytellers. Each rock sample, each data point, each photograph is a sentence in the ongoing saga of the volcano. They interpret these fragments, weaving them into narratives of birth, destruction, and renewal. The lava bombs scattered across a field are not just debris, they are the punctuation marks of an eruption, frozen mid-flight. The twisted trees and scorched earth are not just damage, they are the aftermath of a drama that began deep below when magma forced its way upward, cracking the crust and boiling the groundwater. In every observation, the volcanologist seeks not just to record, but to understand. What is the volcano telling us? What secrets does it whisper through smoke and stone? There are moments of breathtaking discovery, times when the mountain reveals something wholly unexpected. In 1980, the eruption of Mount St. Helens in Washington state changed everything. Scientists had watched the volcano for weeks as a bulge grew on its north flank, evidence of magma accumulating beneath the surface. But when the eruption finally came, it unleashed a lateral blast, an explosion sideways rather than upward, that flattened forests and hurled debris for miles. This new mode of eruption forced researchers to rethink their models, to realize that volcanoes were more complex and unpredictable than anyone had imagined. The lessons learned at St. Helens have since informed safety protocols and research worldwide. The work of volcanologists is not merely reactive, however. Increasingly, it is proactive, an effort to forecast eruptions before they happen, to give communities time to flee. This is perhaps the grandest quest of all, to turn the volcano from an agent of surprise into a phenomenon that can be, if not controlled, at least anticipated. Networks of sensors feed data into sophisticated computer models, simulating the movement of magma and the flow of gases. Algorithms sift through the noise, searching for the telltale signs of escalation. Each volcano is different. Some grumble for weeks before erupting, others unleash their fury with little warning. The challenge is to read these signals, to know which rumble is harmless and which is the herald of catastrophe. Despite the advances, nature remains a cunning adversary. Eruptions can be preceded by earthquakes, ground deformation, or changes in gas emissions. But sometimes there is little warning at all. The best volcanologists can do is to stack the odds in favor of survival, to buy time when the mountain stirs. Their successes are measured in lives saved, in disasters averted, in the gradual accumulation of knowledge that makes each generation wiser than the last. So the volcanologist persists, undaunted by peril, driven by the need to know. They are not reckless, but resolute, not foolhardy, but fiercely devoted. Their work is a bridge between worlds, the solid ground we inhabit, and the roiling depths that shape our destiny. Each expedition is a step into mystery, each instrument a tool for listening to the Earth's oldest stories. And yet, for all their science, there is always a measure of awe, a humility before forces that dwarf human scale. The volcano is both subject and sovereign, a reminder that we are guests upon a restless planet. In the flicker of lava beneath the stars, in the shimmer of heat above a crater, the volcanologist sees not just danger, but possibility. They listen for the next warning, the next whisper from the deep, knowing that the story of volcanoes is far from finished. Somewhere, beneath the crust, magma stirs once more, setting the stage for another chapter in this ongoing dance of fire and stone. Beneath the hush of the night, as the world settles into gentle darkness, let us turn our gaze from distant eruptions and molten rivers to the most intimate question of all. What does it mean that volcanoes exist, here on this blue planet under our feet? What are we to make of these openings in the earth, these wounds, these fountains of stone and fire? The answer is not simple, for volcanoes are both destroyer and creator, a paradox at the heart of our world. Their story is our story too, and the thread of hot rock that stitches continents together is also woven through our civilizations, our dreams, our very bodies. It is easy, in a moment of awe, to see volcanoes as the planet's rage, colossal tantrums that wipe away landscapes, burying towns and forests, smothering life in ash. The memory of disasters lingers. Pompeii, silenced in a single terrible afternoon. Tambora, whose eruption veiled the world in cold shadow and hunger. The blackened moon of Krakatoa, whose shockwaves circled the globe. Our first instinct is fear, and rightly so. To live in the shadow of a volcano is to inhabit a realm of uncertainty, where the ground itself may betray you with no warning, where the sky may rain fire and stone. But to see only the terror is to miss the greater truth, for volcanoes are more than destroyers. They are the architects of the world, the givers of soil and air, the midwives of continents. In their violence lies the seed of creation, and in their aftermath life flourishes anew. The paradox, so profound and subtle, runs through every eruption, every cooled basalt plain, every fertile valley born from ancient fire. Consider the planet itself, long before eyes gazed up at the stars, or hands drew maps on parchment. The early Earth was a world of ceaseless volcanism. its surface racked by eruptions so vast that the imagination falters. The air was thick with steam and volcanic gas, the land black and molten. In this crucible the crust took form, cooling and cracking, floating atop the restless mantle. Volcanoes built the continents, raising mountains from the depths, spewing forth minerals and elements that would one day be gathered into living cells. On the flanks of ancient volcanoes, the first soils were born. Ash and lava, weathered by wind and rain, broke down into rich mineral beds, potassium, phosphorus, trace metals. These nutrients, scattered by eruption, made possible the earliest forests, the first flowering of plants. In the shadow of the fire mountains, life found purchase, clinging to the new land, transforming barren rock into green abundance. Even now the world's most fertile soils, those that sustain rice paddies in Java, vineyards in Sicily, coffee groves on the slopes of Kilimanjaro, owe their richness to the legacy of eruptions long past. But the gifts of volcanoes are not only of earth and stone, they have shaped the very air we breathe. When the planet was young, its atmosphere was a choking shroud of carbon dioxide, water vapor, and noxious gases. Volcanoes, in their tireless exhalations, released these gases from the deep mantle, slowly building up the atmosphere's mass. Over eons, as life emerged and oxygen began to accumulate, volcanic gases continued to cycle through the air, driving the great balances of climate and chemistry. Without volcanoes, the Earth would be cold and airless, a silent rock adrift in space. The oceans, too, are the children of volcanic breath. Water, trapped in minerals deep below, was brought to the surface by volcanic eruptions, released as vapor and rain. The primordial seas filled drop by drop, until at last the world was blue. Even today, the hydrothermal vents that lace the ocean floor, underwater volcanoes in perpetual eruption, pour out heat and minerals, sustaining entire ecosystems of strange, glowing life. Here, in the dark, far from sunlight, chemistry and heat, spark a second genesis. Tube worms, blind shrimp, and microbes feed on volcanic bounty, their existence a testament to fire's hidden generosity. To contemplate these gifts is to realize that volcanoes are not aberrations, but necessities. They are not intruders in a peaceful world, but its very engine, cycling matter, renewing soil, shaping air and water. Their violence is not mindless, but part of a planetary choreography, a dance that has played out for 4 billion years. Through destruction, they make room for new life. Through upheaval, they create the landscapes we call home. And yet, for all their power, volcanoes are not indifferent to humanity. They have shaped our fate in ways subtle and profound, leaving marks not only on the land, but on our cultures, myths, and minds. The first humans, wandering the Rift Valley of Africa, would have seen volcanoes on the horizon, smoking, glowing, rumbling. They would have gathered obsidian from cooled flows, fashioning tools sharper than any bone or stone. Perhaps they told stories of the fire mountains, warning of their anger, or praying for their favor. The volcano was both threat and promise, a source of death, but also of the raw materials that made civilization possible. As time passed, humans settled in the fertile valleys around volcanoes, drawn by rich soils and abundant water. Cities rose on the slopes of Etna, Vesuvius, Fuji, and Merapi. Temples and palaces stood within sight of craters, their builders acutely aware of the risks. To live near a volcano was to gamble with fate, but also to reap its rewards. In Hawaii, the goddess Pele was honored as both creator and destroyer, her lava flows feared and revered. In Japan, Mount Fuji became a symbol of beauty and endurance, its eruptions woven into poetry and prayer. In Iceland, the people learned to read the signs of fire and ice, adapting their lives to the whims of the land. Sometimes the volcano's patience would end, and disaster would follow. The ruins of Pompeii and Herculaneum, entombed in ash, are reminders of this bargain: life and death, harvest and loss. Yet even in tragedy, the volcano's legacy endures. Excavations reveal not only the fragility of human life, but the resilience of culture. Artifacts preserved in ash, frescoes untouched by time, tell of ordinary days interrupted by the extraordinary. In the centuries that followed, the land around Vesuvius remained inhabited, its fields farmed, its slopes climbed by pilgrims and scientists alike. The volcano, it seems, offers no final answer, only an ongoing dialogue between earth and people, danger and opportunity. In other times and places, eruptions have changed the course of history in ways almost invisible to those who lived through them. The great eruption of Tambora in 1815, half a world away from Europe and America, altered the climate of the entire planet. The following year, known as the Year Without a Summer, brought crop failures, famine, and migration across continents. Artists painted sunsets tinged with volcanic dust. Writers, shivering in cold June evenings, penned stories of gloom and wonder. Among them, Mary Shelley's Frankenstein, conceived in the shadow of Tambora's ash. Here, the volcano's reach extends not only into fields and forests, but into the imagination itself, shaping the stories we tell about creation, destruction, and the thin line between. Volcanoes have also been teachers, their eruptions forcing us to reckon with the limits of knowledge and the necessity of humility. For centuries, the causes of eruptions were shrouded in mystery. Priests and oracles interpreted the signs: strange clouds, trembling ground, rivers turned to mud. With the rise of science, the study of volcanoes became a quest for patterns, explanations, predictions. Seismographs, gas sensors, satellites. These tools have revealed much, but the volcano remains, in many ways, inscrutable. Even now, forecasts are often uncertain, and the line between safety and peril is drawn in shifting ash. Yet this uncertainty is itself a gift. It reminds us that we live on a planet in motion, one whose rhythms do not bend to our will. It teaches us to listen, to pay attention to the small tremors, the scent of sulfur, the subtle swelling of the land. In this listening, there is a kind of reverence, a recognition that we are not masters of the earth, but participants in its ongoing story. There is another, deeper connection, a thread that runs from the heart of the volcano to the beating heart of every living thing. The elements forged in the earth's mantle, brought to the surface by fire, are the same elements that course through our veins and bones. Iron, magnesium, calcium, silicon. These are the building blocks of rock and blood alike. When volcanoes erupt, they recycle the deep interior, mixing the old and the new, sending forth the raw materials for life. In a sense, we are all children of volcanoes, our bodies composed of ancient ash and molten stone, our breath mingled with the exhalations of a restless planet. This kinship is both humbling and wondrous. It means that the stories of geology and biology, of fire and flesh, are not separate tales, but chapters in a single epic. When we watch a volcano erupt, we are witnessing the planet's memory in motion, a reminder of the cycles that have shaped the world and made us possible. The destruction we fear is also the renewal we depend upon, and the boundary between the two is never fixed. In the modern age, our relationship with volcanoes is changing yet again. We study them from space, monitor their every tremor, attempt to harness their heat for energy. In Iceland, geothermal power plants tap into volcanic warmth, turning the fury of the earth into light and warmth for cities. In Hawaii, scientists walk the edges of new lava flows, mapping the birth of land in real time. Around the world, teams collaborate to share data, to predict eruptions, to warn those at risk. The goal is not to conquer the volcano, but to live alongside it, to understand its moods, to respect its power, to find ways to adapt and thrive in its shadow. There are those who dream even bigger, to use the heat of volcanoes to melt ice in frozen worlds, to terraform barren planets, to seek life in the vents of alien seas. The lessons learned on Earth in the heat and ash may one day guide us as we reach beyond our home, searching for the spark of existence elsewhere. The volcano, in this vision, becomes not just a threat or a wonder, but a bridge, a link between worlds, between past and future, between what is and what might yet be. And so, as the night deepens and the stars wheel overhead, the story of volcanoes continues, unfinished, unresolved, an endless interplay of fire and life. The next eruption may be years or centuries away, or perhaps brewing even now beneath some silent peak. The earth is restless, and in its restlessness we find our own place, fragile, grateful, awed. The volcano's tale is not one of endings, but of cycles, of destruction and creation, terror and hope, silence and thunder. Somewhere, deep below the surface, molten rock is rising, gathering for a journey it has made countless times before. The world waits, listening, as the heartbeat of the planet echoes through stone and soil. And in that quiet, uncertain moment, we remember that we, too, are shaped by fire, our existence a testament to the beauty and danger of living on a world alive with flame. As our journey through the fiery heart of volcanoes gently drifts to a close, like a comet tail fading into the hush of space, may the quiet wonder of molten realms settle softly in your dreams. Let this peaceful glow invite you to return, where more cosmic mysteries await to unfold beneath the starlit veil. Until then, rest well beneath the vast, dreaming sky.